As we move on to our last chapter in our coursework here in math in STAT200, we're going to be looking at bivariate data and trying to examine relationships between sets of variables. And so in the first lesson of chapter 3, we're going to be focusing in on those bivariate variables that can be represented in a contingency table or a two-way table, where we have either two categorical variables, two quantitative variables, which actually the quantitative variables will be in lessons 3.2 and 3.3, or we may have one categorical variable and one quantitative variable, and we want to examine the relationship between them. So bivariate data, bi just means two, variate means variables. So we're going to be examining relationships between two variables. When we get to studying relationships between two quantitative variables, we'll be making a scatter plot. And our scatter plot's purpose is to kind of allow us to see how these two variables are related to one another. Is there any kind of a pattern in that scatter plot? In other words, as the value of one variable increases, what's happening to the value of the other variable? Is it also increasing, or is it rather decreasing, or is it really seems to have no effect on that other variable? So we'll be getting into greater depth with regards to scatter plots when we move on to sections 3.2 and 3.3. But we want to understand there are really three different kinds of relationships with bivariate data. As I mentioned, you might have one qualitative or categorical variable, and the other might be quantitative or numerical. Both of them might be categorical, or we might have two quantitative variables. And again, we'll study those two quantitative variables in sections 3.2 and 3.3. Okay? So we're going to be looking at these contingency tables, which is really just a fancy name for a table where you've got values of variables displayed. And we're going to be calculating some percentages and making some graphs from those percentages. So let's say, for instance, that the National Highway System Designation Act of 1995 allows states to set their own highway speed limits. Most of the states have raised the limits. The November 2008 maximum speed limits on interstate highways for cars and trucks by each state are given in this table. And these are in miles per hour. So you can see all 50 states are represented. We can see what the maximum speed for the car in that state is, and we can see what the maximum speed for a truck in that state is. We want to start by building what's called a cross tabulation of those two variables, which are vehicle type and maximum speed limit on interstate highways. And we're going to start by expressing the numbers in our cross tabulation in frequencies. So how many states had a maximum speed limit of 55 for cars? How many states had a maximum speed limit of, say, 55 for trucks, and so on? So here's our data. We've got to go into this table and we've got to count how many cars, or how many states, had a maximum speed limit of 55 for cars and then for trucks. How many had a maximum speed limit of 60 for cars and then for trucks, and so on. So let's say, for instance, we're looking at the 55 mile per hour speed limit. Go into your car column, and if you follow down the car column, you notice that the first state that has a maximum speed limit of 55 for car doesn't exist. There are none. So the number of states with a maximum speed limit of 55 for cars is equal to 0. But look in your trucks column. In your trucks column, you see that the first state we encounter that has a maximum speed limit of 55 for trucks is the state of California. So there's one. Also the state of Illinois. There's a second. Also, the state of Oregon has a maximum speed limit for trucks equal to 55. And I know there's one other. I feel like I'm missing it. That last one that has a maximum speed limit of 55 for trucks is the state of Ohio. So there are 4 states that have a maximum speed limit of 55 for trucks. So the total number of states that have a maximum speed limit of 55 for cars and trucks is equal to 4, just 0 plus 4. So we can do the same thing with 60 miles per hour. If you go through your cars, you see that there's 1 state that had a maximum speed limit of 60 and 3 that had a maximum speed limit of 60 for trucks. So a total of 4 for 60 miles per hour. And continue to do so for 65, for 70, and for 75. So altogether, we have 50 states. If we add up the number of cars that had a maximum speed limit of 55, 60, 65, 70, and 75, that should add up to 50 because there are 50 states represented. If we add the trucks together, 4 plus 3 plus 20 plus 13 plus 10, that's also 50. So we know we haven't missed any, and we've got a total of 100 counts or frequencies in this table. So now we want to calculate the percentages based upon the grand total, and we're going to make a bar graph that displays our results. So here's our cross tabulation. So the grand total was 100. So for 55 miles per hour, there were 0 cars that had that maximum speed limit. 0 out of 100 is 0%. There were 4 trucks that had that maximum speed limit, so 4 out of 100 is 4%. And the total number of cars and trucks that had a maximum speed limit of 55 was 4, and 4 out of the grand total 100 is 4%. Same thing with 60 miles an hour. 1 car out of 100 is 1%. 3 trucks out of 100 is 3%, and so on, for all other maximum speed limits. So these are our percentages based upon the grand total number of cars and trucks represented in our data set. I cheated and used Minitab to make this histogram or bar graph, but I want you to notice that I just made a scale that had equal intervals, 55, 60, 65, 70, 75. Those are all 5 miles per hour apart, just like in our data. We had 4% of all cars and trucks that had a maximum speed limit of 55. So you notice the bar above the 55 is reaching a height of 4%. We had 4% that had a maximum speed limit of 60 miles per hour. So you notice the bar above the 60 is also at a height of 4%. The most common maximum speed limit was 65 miles per hour. 38% of our states had cars or trucks that had a maximum speed limit of 65. So the bar above the 65 reaches a height of 38%, and so on.